Yo, what's up everyone? Today we're going to be doing some practice with colligative properties. So let's get started with the first question, which is the 2017 USNCO local exam number 6. It asks which aqueous solution has the highest boiling point. Since we're dealing with boiling point, we know that we're going to need to use change in TB equals KB times M times I. So change in TB is the change in the boiling point or the boiling point elevation. KB is the constant, M stands for molality, and I stands for the Van 't Hoff factor. Since we're trying to get the highest boiling point, we know that we're going to be trying to maximize the value of these three multiplied all together. But the thing about this is that, first of all, the question tells us that we have an aqueous solution. What that implies is that all of these answer choices are being dissolved in water. And if all these are being dissolved in water, then all the KB values for all these answer choices are going to be the same. They're all going to be 1.86. So we're really looking for what value maximizes M times I. But you notice that all these answer choices are dealing with a molality of 1 molar. What that means is that the molality is also not going to count. What we're really looking for here is which of these answer choices maximizes the Van 't Hoff factor, which is I. So let's look. If you look at CH3COOH, that is a weak acid. And since it's a weak acid, its Van 't Hoff factor is going to be basically 1. If you look at sulfuric acid, which is H2SO4, that's a strong acid that's going to have a Van 't Hoff factor of 3. And that's because H2SO4 is going to dissociate into H+, and SO4 2-. So it has a Van 't Hoff factor of 3. H3PO4, on the other hand, is a weak acid, so its Van 't Hoff factor is going to be about 1. And the last one, glucose C6H12O6, is a it's not even an electrolyte, so its Van 't Hoff factor is 1. So out of all these answer choices, H2SO4 has the highest Van 't Hoff factor, and therefore it has the highest boiling point. So our answer is B. Let's go to the second question, which is the 2015 USNCO local exam number 6. Which aqueous solution exhibits the largest freezing point depression? So in this case, we're dealing with freezing point depression. So change in TF equals KF times M times I. And since we want the largest freezing point depression, we're trying to maximize the value of KF times M times I. We're trying to maximize this value. So which one of these is going to stay the same? Well, we know that we have an aqueous solution again. So KF is going to be 1.86 degrees Celsius per molality. So all these answer choices are going to have the same KF value. What we're really looking at is which of these answer choices maximizes the value of the molality times the Van 't Hoff factor. So let's go through our answer choices and look through all of them. We have 1.0 molar KBr. KBr, potassium bromide, is a salt. Therefore, its Van 't Hoff factor is going to be 2. It's going to dissociate into potassium ions and bromide ions. So its M times I value is going to be 2. Let's look at the other answer choices. We have 0.75 molality C6H12O6. That has a Van 't Hoff factor of 1 because, again, it's a non-electrolyte. Therefore, its M times I value is going to be 0.75. Let's look at C, which says 0.5 molality MgCl2. MgCl2 is a salt, therefore it has a Van 't Hoff factor of 3. It's going to dissociate into Mg ions and 2 chloride ions. So its M times I value, M times I, is going to be 1.5. The last one is 0.25 molality Ga2SO43, which is a strong electrolyte. So it's going to have a Van 't Hoff factor of 5. It's going to dissolve into 2 gallium ions and 3 sulfate ions. So its M times I value is going to be 1.25. So out of all these answer choices, the one with the greatest M times I value is going to be the KBr. So KBR, one molality KBR is going to have the largest freezing point depression. So our answer is A. Let's go to the third question, which is the 2019 USNCO local exam number 6. Which solute, when dissolved in 1 kilogram of water, will give the solution with the highest boiling point? We're dealing with boiling point, so we have change in TB equals KB times M times I. And again, we're looking for the highest boiling point, so we're trying to maximize the value of KB times M times I. We're trying to maximize this value. So which of these answer choices, or which of these KB, M times I, which of these are going to stay the same? Well, KB is going to stay the same. And the reason we know this is because, again, we're dissolving in water. Water has a KB value of 1.86 degrees Celsius per molality. So KB stays the same. And Van 't Hoff factor is also going to stay the same. If you look at all your answer choices, these are these long organic compounds. So they're going to be non-electrolytes. So Van 't Hoff factor is going to be right about 1. So what we're really looking at is which one of these answer choices has the greatest molality. Molality is moles of solute over kilogram of solvent. And the thing about this definition is that one of these is going to stay the same in our case. We know that the kilogram of solvent is going to be 1 kilogram of water. And we're told that in the problem, where it's dissolved in 1 kilogram of water. So what we're really looking for is which of these answer choices maximizes the moles of solute. Moles of solute is going to be grams of solute over the molar mass of that solute. And since we have 50 grams of all of these solutes, we know that we have 50 grams. What we're really looking for is which of these answer choices decreases or minimizes the value of the molar mass. Because the lower molar mass you have, the greater this number becomes, and therefore the greater this number becomes, and therefore greater this number becomes, and therefore greater this number becomes. So it's like this chain reaction. So what we're really looking for is which of these answer choices has the lowest molar mass. So let's go through all the answer choices and look at the molar mass, starting with the ethylene glycol. So let's start with the HOCH2CH2OH. That has a molar mass of about 62 grams per mole. Let's look at the second one, HOCH2COOH. That has a molar mass of 76 grams per mole. Then we have HOCH2CHOCH2OH. That has a molar mass of 92. But our last option, which is HCOCH, that has a molar mass of 58 grams per mole. And that's the one with the lowest molar mass. So our answer here is D. And this should kind of intuitively make sense. If you look at all your answer choices, out of all of them, D has the one that kind of at least looks the smallest. And so therefore D has the lowest molar mass, which makes it have the greatest molality, which makes it have the greatest boiling point. Let's look at the last question, question 4, which is the 2016 USNCO local exam number 6. An aqueous solution of potassium sulfate has a freezing point of negative 2.34 degrees Celsius. What is the molality? So we're dealing with freezing point, meaning the equation we use is change in TF equals KF times molality times I. Since at the end we're going to want molality, let's just rearrange this equation to give us molality. So molality is going to be change in TF over KF times I. And now let's look at the problem to see which of these numbers we're really given. We are given change in TF. And the reason we're given that is because first we have an aqueous solution. An aqueous solution is just water. And water is going to freeze at 0 degrees Celsius, which means that if our new solution freezes at negative 2.24 degrees Celsius, our freezing point depression was 2.24. So M equals 2.24 degrees Celsius over, And we also know Kf, and that's because we have an aqueous solution. An aqueous solution means water, of course, and water has a Kf value, Kf of 1.86 degrees Celsius per molality. So 1.86 degrees Celsius per molality. And the last one is the Van 't Hoff factor. We're dealing with K2SO4. K2SO4. K2SO4 is a salt, which means that it's going to be a strong electrolyte, and therefore it's going to dissociate into K+, and SO4 2-, which means its Van 't Hoff factor is 3. So let's plug that last bit of information in, times 3, and all that there's left to do is solve for M. And once you do, you realize M is 0.401 molality. And so our answer here is A. And that was it. I hope this was able to give you a better understanding of how colligative properties work in the context of problems. I hope you were able to learn something, and I'll see you later. Thank you.